Imagine sitting in a room with friends, listening to a casual conversation. Everyone else is relaxed, laughing, and moving quickly from topic to topic. But inside your mind, something completely different is happening. Your brain is actively dissecting the interaction. You are noticing microscopic shifts in posture, measuring the subtle tone of someone's voice, and instantly generating multiple interpretations for why someone phrased a sentence in a specific way. Hours later, long after everyone else has forgotten the conversation, your mind is still processing the event. You are running simulations, looping the dialogue, and questioning how the entire interaction could have gone differently. You are experiencing metacognition, the ability to continuously observe and think about your own thinking. One part of your mind participates in the moment, while another part acts as a permanent internal observer, constantly evaluating everything that is happening. This constant mental looping carries a heavy physiological toll. You can spend an hour sitting perfectly still in a quiet room and emerge feeling completely exhausted, despite zero physical exertion. Profound exhaustion marks the high-performance output of a distinct neurological operating system running at its maximum threshold. To understand why your mind operates this way, we have to look at a specific neural architecture called the default mode network, or DMN. This network behaves unlike almost any other biological system. When you stop focusing on a specific external task like a math problem or physical work, your brain does not shut down. Instead, the DMN immediately activates. In this supposedly resting state, your brain begins a complex internal simulation. It starts connecting past memories, pulling present variables, and projecting multiple future outcomes. Early humans relied on this constant mental simulation to predict physical threats and survive. Today, with fewer predators around, that same predictive software runs pattern recognition algorithms on your career decisions, personal identity, and social interactions. Individuals with a dominant DMN possess exceptional pattern recognition. Their brains automatically detect microscopic inconsistencies in human behavior and catch subtle social signals that bypass everyone else. That feeling of a mind that refuses to shut off is exactly this: your brain's highest-level survival and predictive software running in a modern environment, completely lacking a kill switch. Running this invisible internal simulation continuously requires massive biological resources. This gauge illustrates a severe biological imbalance. The human brain makes up roughly 2% of your total body weight, yet it demands 20% of your body's entire energy supply. This intense energy draw is driven by cognitive depth, the thorough, multi-layered processing of simple information. Take a neutral phrase like, "I guess that's fine." A standard brain accepts the literal meaning and moves on. An analytical brain explores it through multiple layers of tone, context, and intention. Analyzing that single moment forces multiple neurological systems to work at once. The prefrontal cortex manages reasoning, the hippocampus pulls memories, the amygdala monitors emotion, and the DMN generates reflections. They fire simultaneously. It is identical to running multiple heavy software programs on a single computer. The processing power bottlenecks, the power draw spikes, and the system starts to overheat. That profound exhaustion you feel after a completely ordinary conversation is the unavoidable direct physiological result of carrying a massive cognitive workload. Why would human biology preserve a mental trait that causes such immense physical exhaustion? This system thrives by mapping out every hidden variable, providing the biological foundation for divergent thinking. The same internal simulations that cause rumination also allow the brain to explore possibilities that a more efficient mind would ignore. This neurological setup thrives on associative thinking, the ability to connect ideas that appear entirely unrelated. Instead of searching for one correct answer, your brain relentlessly maps out all possible answers. Many of history's most effective innovators and artists relied on this specific mental architecture. Their minds rarely stopped exploring, allowing them to detect invisible patterns that others missed entirely. Effectively guiding an overactive mind requires regulating its internal temperature and energy supply. You must deliberately provide your brain with low input periods. Walking in nature, listening to music, or simply daydreaming gives the default mode network the quiet it needs to process its massive data load without overheating. A deeply analytical mind operates at a level of curiosity and imagination that most people rarely experience. When properly cooled and directed, the noise snaps into focus, and the same brain that generates endless, exhausting questions begins providing extraordinary answers.